All right, this is paper 2, 2019, question number 2. This question is about pulleys. Part 1 says an object of weight 100 newtons is being lifted using a simple machine. Part A, give the name of this simple machine. Okay, so there are 3 types of pulleys. You have your fixed pulleys, your movable pulleys, and then you have the combination of those two, which is this one, and the name of that type of pulley is, name of this simple machine is a block and tackle pulley. Calculate the mass of the object using the gravitational constant given, 9.8 meters per second squared. So we know the weight, and we're given the gravitational constant. The formula that relates those two is this one. Weight is equal to mass multiplied by gravity. You might remember this little formula triangle. We can use that to transpose the equation to make mass the subject. So that's mass is equal to weight divided by the gravitational constant. 100 newtons is the weight. We get that from here, divided by 9.8. And that's going to give us 10.2 kilograms. Okay. What is the gain in gravitational potential energy of the object if it is lifted 4 meters? Gravitational potential energy, 4 meters, that's the height. What's the formula for gravitational potential energy? So the gain, so from zero, from where it was started on the ground, where it has 0 gravitational potential energy, to the height of 4 meters. So it went from 0 to, let's calculate. Gravitational potential energy is equal to mass times gravitational constant multiplied by the height. We're going to use the same gravitational constant given, 9.8. The mass we just calculated in the first part is 10.2 multiplied by the gravitational constant. Well, that's just the weight. You don't even need to calculate that. We can just plug in 100. But if you want to do that, you want to show everything, you can plug in 10.2 times 9.8. You get back 100. Or you can also realize that gravitational potential energy is just equal to the weight times the height. So we just multiply 100 times 4 and we get 400. And the unit for gravitational potential energy is joules. Okay. Next part says to state the velocity ratio of the machine. Now, there's no formula for this, okay? The velocity ratio for a block and tackle pulley, all we need to do is count the ropes. Count the ropes. So let's go back to the diagram and look. And we're going to count every rope that is not attached to the load. So that would be this one, that one, and this one. So we do not count this one. That's the one that we're applying the effort on. We don't count that one. Okay. And so that's 3 ropes we counted. So the velocity ratio, VR, is equal to 3. Moving right along, calculate the distance moved by the effort. Okay, now there is a formula for this one. The distance moved by the effort is related to the velocity ratio and the distance moved by the load by this formula. Okay, so velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load. So if we rearrange that so that we have an expression for the distance moved by the effort, that's going to be velocity ratio multiplied by the distance moved by the load. We just determined that the velocity ratio is 3, and the distance moved by the load would be the 4 meters that the load was lifted. Okay, so multiply that by 4. And so that gives us 12 meters. Then finally, we're to calculate the mechanical advantage of the machine. We have a formula for that as well too. The mechanical advantage is the ratio of the load to the effort. So we're talking about the amount of force, the load and the effort. So the load we know is 100 newtons, and the effort applied, we were told, was 40 newtons right there. So if we work that out, 100 newtons over 40 is going to give us a velocity ratio of a mechanical advantage of 2.5. Okay? There are no units for velocity ratio or mechanical advantage because we're comparing the same type of quantities. For velocity ratio, it's length and length, so the units cancel out. For mechanical advantage, it's force and force, so newtons and newtons, and so they cancel out. So it's just 2.5 is your answer. All right, and finally, using your answers from C and E. Okay, so our answer from C, I think that should probably say using our answers from E and C and F. Right, so we're meant to calculate the efficiency. So the relationship between efficiency, mechanical advantage, and velocity ratio is this one. Efficiency is equal to mechanical advantage over velocity ratio. Mechanical advantage is what we found in part F. Okay, so that should say F. And velocity ratio is what we found in part D. So that should say D. Okay. So let's go ahead and do that. So the mechanical advantage we found was 2.5, and the velocity ratio was 3. Okay. For machines, efficiency is always going to be less than 1, unless you're like super genius and you made something that has a really high efficiency. Most machines, most practical machines, if you have an efficiency of 70, 80%, that's pretty good. Okay, so 2.5 out of 3 gives us an efficiency of 0.83. Okay, and again, there are no units here. Sometimes the question would go further and ask you to give the percent efficiency, and so all you do is change this into a percentage. So instead of 0.83, that would be 83%. We'd say it's 83% efficient, the block and tackle machine. And that's the end of question 2.